Hello, Matthews Gatos here. In this video, we're going to look at how to interpret a linear graph. Let's get started. First thing I want to talk to you about is the y-intercept. Now, the y-intercept, I can see that graphically. It is the point that the graph crosses the y-axis. Because it is a point, it has coordinates, and those coordinates are 0 and y. Because x has a value of 0, the y-intercept is sometimes called the initial or the beginning value. To find that algebraically, I would let x be 0 and solve for y. Let's look at an example. So in this one here, I have a graph showing volume of gas as a function of distance traveled, volume versus distance. If I look at the vertical intercept, that's where it crosses the y-axis, and that point is 0 and 100. What does that mean? Well, that's the amount of gas in the tank before you start driving. Specifically, there was initially 100 liters of gas in the car. Let's talk about the x-intercept. So the x-intercept graphically is the point at which the graph crosses the x-axis. Since it's a point, it has coordinates, and those coordinates are x0. Algebraically, if I want to figure out what the x-intercept is, I let y be 0 and solve for x. So let's go back to that same example, but this time I want to find the horizontal or the x-intercept. So looking at that graph, I can see that the x-intercept is 800 and 0. So that represents how long you can drive until the tank of gas is empty. Specifically, you can drive 800 kilometers on 100 liters of gas. So that's the meaning of the horizontal and vertical intercepts. Let's review again rate of change. We talked about this in a previous video. Rate of change is the change in the dependent variable, that's y, over a change in the independent variable, that's x. So let's go back to this example and find and interpret the meaning of the rate of change. So the rate of change, again, let's look at our beginning value and our end value. We begin the graph at the point 0 and 100, the y-intercept. We end the graph at 800 and 0, which is the x-intercept. So to know the change in the dependent variable, I'm going to take my ending y value and subtract my beginning y value. So I'll do 0 take away 100. For my independent variable, I am going to look at the change of my end x value to my beginning x value, which would be 800 minus 0. So let's simplify that. 0 take away 100 is negative 100 over 800 take away 0 is 800. Now let's reduce that. I can see they have a common factor of 100, so I can divide each by 100, and I end up getting negative 1 over 8. So that would be my rate of change in lowest terms. Now, rate of change also needs units, and those units were liters per kilometer. So what does this rate of change tell me? It tells me that you use or lose 1 liter of gas for every 8 kilometers driven. So let's look at how I can find x and y intercepts algebraically. So if I want to find the x-intercept is all about x. I don't need y. So I'm going to let y be 0 and solve for x. So in my function, f of x equals 2x plus 5, I let y, which is really f of x, be 0. And then I'm going to solve for x. So I use reverse order of operations, subtract 5 by both sides. 5 take away 5 is 0. 0 take away negative 5 is 0 take away 5 is negative 5. And then divide both sides by 2. So I get x is equal to negative 5 over 2. So that is going to be where I cross the x-axis. Of course, I want to list that as a point. So the x-intercept as a point would be negative 5 over 2 and 0, which is really negative 2.5. So the function f of x equals 2x plus 5 crosses the x-axis at negative 5 over 2 or negative 2.5 and 0. So I can just plot that point on my graph right there. Let's now figure out the y-intercept. So for a y-intercept, I want y, I don't want x. So let's let x be 0 and solve for y. So in my function f of x, I'm going to let x be 0 and solve for y. So remember, f of x is the same as y, and I have 2 times 0 plus 5. 0 plus 5 is 5. So that's my y-intercept. As a coordinate would be 0 and 5. So let's look at that on the graph. So f of x equals 2x plus 5 crosses the y-axis at 0 and 5. So I can plot that point right there. So now that we have 2 points, we can connect the dots to find what my linear graph looks like, but I always like to find at least one other point. So I'm going to pick a point between negative 2.5 for x and 0 for x for the y-intercept. So to find one other point on the line, you can pick any x value. I'm going to choose an x value that's between the x and the y-intercept. So I can pick any x value. I'm going to pick -1. So I replace x with -1. So f of x, which is really just y, is equal to 2 times -1, -2, plus 5. -2 plus 5 is 3. So the point that I chose is -1 and 3. You could choose another point. That's just what I chose. So if I go onto my graph and I want to show that f of x equals 2x plus 5 passes through that point, -1 and 3, I can put that on the graph as well. So what I want to do is I want to put all of those 3 points together on a graph and then connect the dots. So I'll start with my x-intercept, which was -2.5 and 0. I'll graph my y-intercept, which was 0 and 5, and the point that we just found, -1 and 3. So I just have to connect the dots and then label my linear function. F of x equals 2x plus 5. So that's how you find your x and y intercepts algebraically and use them to graph. Speaking of graph paper, I see that you have some graph paper. Therefore, you must be plotting something. So I hope this video helped. If it did, please give it a thumbs up and hit subscribe so I can help more mathies just like you. I'll see you for the next one.